Okay, the last thing that we have to do is the sum formula, you guys. So for this, the sum formula, if you wanted to find out what all of the terms in a sequence add up to, what we're going to do is we're basically going to find the average. So we're going to take the first term, and there's an alternate here which I don't ever use. I always use this other one, although that alternate could come in handy today with some of the ways they set things up. But we always take our first term, add it to our last term, divide that by 2, and then multiply by the number of terms that there are, n. Okay, n can be tricky, and I'll tell you why in a second. So example 4 says use the sum formula, either one. The other one, I mean, this one works, you guys. I'm not trying to say don't use it. I'm just saying this first one makes a lot more sense. Okay, so use the sum formulas to figure this out. What we're going to do is we're going to take the first term, we're going to add it to the second term, then divide by 2, just like it says to do here. We're finding the average. So 100 plus 2 divided by 2 is equal to 102 over 2, which is equal to 51. Now we're going to take that 51 and we have to multiply it by our n. So how many terms were there in this sequence? Okay, so that could be a little bit tricky to find. If you want to know how many terms there were in this sequence, the easiest way to do that would be to, plug it back into one of your equations. You know a1, you know an, right? So you could say that a sub n is equal to a sub 1, which is 2, plus n minus 1 times the common difference. We know the common difference in this case is 2. Okay, and then I know the nth term is actually 100 here. I don't know what term it is, right? So that's what I'm going to be solving for. So I can say 100 is equal to 2 plus, I'm going to just distribute this out, 2n minus 2. Notice I have a 2 minus 2. Those go away. So 2n is equal to 100. Therefore, n must be equal to 50. So there are 50 terms here in this sequence. I'm going to take my average there and multiply it by how many terms there are in the sequence, which is 50. If I do 50 times 51, I end up with 2550, and that is my answer. All right. So then for 4b, very similar here. Notice they give me n, they give me a sub n, they give me the common difference, right? So the things that I need to find the sum are I need a1, and I need an, and I need n. So notice they gave me an, they gave me n, but I got to find a1. All right, so I can do that. I can just say, okay, an is equal to a1, right? So I'm going back to my original formula, plus n minus 1 times d. Plug in what we know. an is 240. I'm looking for a1. I know that n is equal to 16, so this will be 16 minus 1, which is 15. And I know d is 8. Okay, so then I know that a sub 1 is equal to, if I do 8 times 15, 8 times 15 is equal to 120. So if I subtract that from both sides, I know that a sub 1 is equal to 120. All right, so 120 is a sub 1. Now I can use my sum formula. All right, so I got 120 plus 240 divided by 2 times 16. All right, so let's just do that out really quick. So if I do 120 plus 240, that's 360. Divide that by 2, I get 180. 180 times 16 gives me 2,880, and that is your answer. All right. So example 5 now, and I know this is getting very long, this lesson, but 2 more examples. Example 5 says find the first 3 terms in the sequence. All right, well, to find the first 3 terms, what's crucial is that you know A1 and you know D. Like if you know those 2 things, then you're good to go, right? So let's try to figure that out. So we know that the sum of the terms in the sequence is 120. So I could say, all right, well, Sn is equal to, n times a1 plus an over 2. Plug in what we know. So I can say 120 here is equal to 8 times a1 plus 36 over 2. Okay, so I can do some simplification here. Since this is being multiplied, I can just make that a 4, right? And so what I'm left with is 120 is equal to 4 times a1 plus 36 times 4. 36 times 4 is 144. Okay, so I can subtract that from both sides. 120 minus 144 is equal to negative 24. Okay, divide both sides by 4 to get a1. So we say a1 now is equal to it's negative 6. Okay, so we have negative 6 as our first term. Do we know d? That's our other question here. So to find d in this case, what we're going to have to do is we're going to have to plug this into our original formula now. Okay, so I know this is a lot of work. I'm not going to do 5b to save some time here, but here we go. So we know that a sub n is equal to a sub 1 plus n minus 1 times d. I'm trying to find d, so I have to know the rest of these things here. So a sub n is 36, right? I got that from right here, is equal to a sub 1, which is negative 6, plus n minus, well, we know n. N in this case is 8. 8 minus 1 is 7, so we have 7 times d. So let's add 6 to both sides here. We get 42 is equal to 7d. So if I take 42 and divide that by 7, I get 6. So d is equal to 6. All right, so the first 3 terms of the sequence will be negative 6. That's my a1. And since my common difference is 6, I'm going to add 6 to both, sorry, not to both sides, but add 6 to the previous term. I get 0. And then if I add 6 again, I get 6. So we get negative 6, 0, and 6. All right, go ahead and try 5b out on your own. I'm not going to do it here, but negative 24, negative 16, and negative 8 should be what you get for your answer on 5b. The last thing is just this thing called sigma notation, you guys. Sorry for the long video. So look, sigma notation. All this is they give you the formula for the pattern, right? Up top tells you the last value of k. So meaning that this thing will have, the last value is 21. So that's your n value. Okay, so it's like the nth term. And then this tells you your first term, the value of the first term. Okay, value of the first term. So to find the sum between these, okay, what we're going to do is, what this is saying is they want you to sum the 9th term to the 21st term. That's essentially what this is saying. Okay, so how many terms are we dealing with? That's what we got to figure out. So most people would say, all right, we take 21, we subtract 9, and that'll tell me how many terms we have, right? So if we do that here, we would end up with 12, but that's not the correct answer. The reason for that is if you include the 9 as your first term, then we have to add that first term in there. So it'll always be the difference of these two things plus 1. All right, so I know in this case that there are going to be 13 terms. All right, so now I could just use, I need to find my first term, obviously. So I can, once I know this, I know that n is equal to 13, right? So now what I need to do is figure out, all this thing means here, you guys, is the sum, this is the sum notation, the sum of the sequence from the 9th term of the sequence to the 21st using this pattern. Okay, so there's 13 pieces here. I know that I can find a sub 1. A sub 1 is equal to, well, I know that since this is 13 here, I guess one of the things that I would have to do is I would have to figure out what, if I plugged in a 1 to my nth term equation. So if I put an a sub n in there, that's equal to a sub 1 plus n minus 1 times d. All right, so if I plug in this 9 to my equation, notice what happens. 5 times 9 plus 6 is equal to 51. Okay, that's the first term in my 13 that I'm doing. Okay, so I don't actually have to go back to this yet. In fact, I don't know that I will actually, so you can forget I actually even said that, because they gave you the explicit equation here. So the first term is that when we plug that 9 in. Okay, the 13th term, since we're looking for the 13th there, is going to be 21, right? So what I do for that one is I'm going to plug that 21 in for m. So I get 5 times 21 plus 6, which is equal to 111. Okay, so there's your first one, there's your last one in this series of 13 terms. Now you just go back to your sum equation. So for that, you just take the first one, add it to the last one, divide it by 2, multiply it by n. N is, in this case, 13. All right, and I know this one's probably going to be a little confusing. This comes out to 1,053. But we'll do some more of these in class. Essentially, they give you the equation here. You're going to plug in, it's as simple as plugging in this guy for the variable, plugging in the guy on top for the variable, and then knowing the difference between them to find n. Okay, so we could create a bunch of those in class, and we'll do some more of those together. But we are out of time. Catch you guys.